Hey there, in this video we are going to look at how we evaluate algebraic expressions and equations. So when we are given an algebraic expression or equation plus a value for the variable or variables, we can evaluate that expression or solve that equation by plugging in the values for the variables and simplifying. And we'll use order of operations when we have it plugged in and we are ready to simplify. So let's go ahead and try number 1. So we have 8x plus 17 minus 2 times x minus 8 for x equals 2. So they want us to evaluate this expression given that x is equal to 2. So we will plug 2 in anywhere there's an x. So right here we'll put a 2 and right here we'll put a 2. So 8x will be 8 times x, or 8 times 2, plus 17 minus 2 times 2 minus 8 in the parentheses. So now we can use our order of operations. Please excuse my dear Aunt Sally. So now we start with parentheses. Now there's nothing inside this first one other than a 2, so we're just going to leave that 8 times 2 plus 17 minus 2 times 2 minus 8. We can't evaluate that. That is negative 6. So parentheses are done. There are no exponents to worry about, so then we move on to multiplication and division. There is no division, but we do see 8 times 2, and we see negative 2 times negative 6. So we can go ahead and multiply those together. 8 times 2 is 16. We still have plus 17, and then negative 2 times negative 6 is positive 12, so plus 12. So now we have multiplication done, and there is no division. So then we move on to addition and subtraction. Now there is no subtraction, so really we just need to add these three numbers together. You can think of, for example, 16 plus 17, get that to be 33, and then add 12 to that. Or for some people, if you add the 16 and the 12, you can do that in your head a little easier because the 6 and the 2 don't require us to carry a number like adding 6 and 7 does. So if you're trying to do 16 plus 12 in your head, for some people it might be easier. That's going to come out to be 28 plus 17. And remember, we can do that because of our commutative property. We can switch the order. So when it's all addition like that. So we have 28 plus 17, which is actually going to give us 45. So however you add those three numbers, you are going to get 45 as your answer. Now on number 2, we're going to look at a different expression. We're going to look at c over 18 minus 6 minus n over 7 plus 9. And they tell us that c is 3 and n is equal to 4. So we are going to go ahead and plug in 3 for c, and we're going to plug in 4 for n. So 18 minus 6, if we look at that part right there, following order of operations, that's essentially like being in a set of parentheses because it's on the bottom of the denominator or in the denominator of a fraction. So we can think of this has to be done before we can do any dividing with 3 in the bottom and 4 in the bottom. So I'm going to leave it 3 over and then 18 minus 6. And when you do 18 minus 6, you get 12. And then minus 4 over 7 plus 9 is 16. Now you'll notice those are not common denominators, but instead of trying to multiply, I noticed that 3 and 12 are both divisible by 3. Whoop, there we go. On top and bottom. And if I divide the top by 3, I get 1. Divide 12 by 3, and I get 4. And then I can do the same thing over here because 4 and 16 are also both divisible by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So they do come out to be the same here. That won't always happen, but 1/4 minus 1/4 is 0. So in that case, it was easier to divide each of those fractions by the common factor from the top and the bottom. That way they then have the same denominator. And then I would subtract those and I get 0 as my answer. Now let's go ahead and try the next two, which are going to be very similar except for it's set up in an equation format and we are solving for one of the variables. So here we are solving for p, and over here we're solving for e. And they give us the variable values as well. So p equals r over v. R is 82 and v is 2. So we can set this up by plugging in 82 for r, which is going to be 82 on top, over 2 for v. And then because the variable p is already by itself and we're solving for that, the concept here when you're solving an equation is to get that variable by itself. It's already there. So we can do 82 divided by 2 to get the value of p, which is going to be 41. Then for number 4, we have a similar concept. So we have E equals mgh. For m equals 2, g equals 8, and h equals 3. So when we plug those into m, g, and h, we get the equation E equals 2 times g, which is 8, times h, which is 3. Now you can multiply these together in any order because it's all multiplication. So because it's all multiplication, personally, I would probably do the smaller two, 2 times 3 multiplied together. And those two give me 6. And then I still have times 8. And 6 times 8 gives us 48. So we get E equals 48. We're going to go ahead and take a look at a slightly more complex example. So you can see that they give us an expression 7x plus 9 over 4y minus 7 plus 4y minus 7 over 7x plus 9. They also tell us that the x value is equal to 13. So anywhere there's a 13, anywhere there's an x in the expression, we're going to place a 13 in that place. Additionally, they tell us that y is equal to 3x divided by 13. So the first thing that I would do is I would notice that there's a variable over here in this fraction that represents y, and that variable is x. So that x, I can actually go ahead and put a 13 in that place. And so that's going to be 3 times 13 divided by 13. And you can do 3 times 13 and get 39 and then divide by 13. Or you can see that 13 divided by 13 is going to simplify to 1. And so that just gives us the number 3. So our y value is actually 3. So anywhere there is a y in this problem, we're going to replace that y value with a 3. So we have enough information now that we can go ahead and plug in. So 7 times x, so 7 times 13 plus 9 on top, divided by 4 times y, so 4 times 3 minus 7, plus the reverse of that fraction. So the reciprocal of that would be 4 times 3 minus 7 over 7 times 13 plus 9. So I would simplify within each fraction first. So if I evaluate 7 times 13 and add 9, 7 times 13 gives us 91, plus 9 is 100. So 100 is on top of the fraction. 4 times 3 is 12, minus 7 is 5. So 100 over 5 is this first fraction, which means this is going to be 5 on top, and this is going to be 100 on bottom, since they are the exact same. Now, obviously, that won't always happen, but in this scenario, it did. Now, we can go ahead and simplify that. 100 divided by 5 is 20. 5 divided by 100 is 1/20th. Depending on if this is multiple choice, and if so, what the answer choices are written as, you may leave it as 20 and 1/20th. You may change it into an improper fraction, or you may put it as a decimal, which would be 20.05. And that 0.05, you can think of this 5/10ths, this 5/100ths as 0.05, because 0.05 is in the hundredths spot as a decimal, and then this fraction here is the number 20, and so it would be 20 plus 0.05, which is how we would get 20.05 if this is in fact a multiple choice written in decimal format. So it just depends how they want the answer, but that would be the answer for this problem. So in summary, we plug values in when we are given, for example, x equals 2 and y equals 7 in an expression like 4x plus 7y or something like that. We are always going to plug in those numbers. So for example, 2 is going to get plugged into the x, and then 7 is going to get plugged into the y right here. So we always plug those values in directly into the letter that they represent, and then we simplify with our order of operations. And for the equations, it's really going to be the same thing. It's just typically it's going to be, for example, E equals that. And so you are just simplifying the odd stuff on the right when this is already by itself over here.